Dan Perry here with another C++ tutorial for Dan on Tech. In this video we will look at floating point numbers and how we do floating point math. For this video what I'm going to do is I'm going to stick to the double. Remember we had the float and the double. The double is a higher precision, stores more accurate numbers. It doesn't really matter for what we're doing in this video, but I'm just in the habit of using doubles, and so we're going to stick with doing doubles here. So the first thing I'm going to do is I'm going to define some doubles, and so let me go ahead and create some double precision values. And here are three. And I've named them F1, 2, and 3 for floating point 1, 2, and 3. And let me go ahead and give them some values. The first one, let's give a value of 12.2. The second one, let's give a value of 3.7. And the third one, let's give it a starting value of 0.0. So we've got a starting value for them. And if we were to just output these numbers, these values, all we're going to see is exactly what we put in. So let's actually do that to start with. And so here we've got our just some couts that output each of those, nothing in between. We've typed the numbers in, we've given them a constant value, and now we're just going to output them. So we should expect to see those numbers displayed as is. And here we go, and if we look, that's what we're seeing, 12.2, 3.7, and 0. Nothing that we didn't expect there. Now what I'm going to do with this is I'm going to go in and put some calculations in, and then we'll see the results of those calculations. And so what I'm going to do first is I'm going to say that fnum3 is equal to fnum1 plus fnum2, and it should add those two together and give us the results. And so we know in our results what we've got. I'm going to put this inside the quotes, this calculation, so we'll actually see what the calculation it was doing. So we made that change, and we'll run it, and we've got a build error. So we've got that build error. You can see I can't type. It should be a lowercase f and an uppercase num. My fingers don't always hit the keys right, and so I got the wrong capitalization. So this time when I look, it's gone in and it has created these variables. It has done this addition, and then it's output fnum1 and 2, and then the new value of fnum3 was the sum of the two, or 15.9, and we can see that that is correct. Well, let me just make a simple change. Let's run it this time and multiply. Remember, the asterisk is for multiply. And so if we run it with multiplication, we'll see that once again num1 and 2 are the same. fnum3 is now 45.14, and if we just look at those two numbers and think about it, that looks about right. So we've got something around 4 and something around 12. So I'm guessing that's the correct answer. Now, nothing we didn't expect there. Might as well do a division of the two just to see what happens with the division. And then I'll do one with parentheses. Okay, and when we do the division, we've taken fnum1 divided by fnum2, 12 something divided by 3 something gave us 3 and a fraction. So once again, it's done the calculations as we would expect. Now, remember we talked about the order of operations, the order of math operations. So if we had multiplication and addition, so I'm going to say maybe times 4, or 4.0. So now it's going to, it says f num1 plus f num2 times 4. And if you remember, we talked about the order of operation, and it says it does multiplication and division first, then addition and subtraction. So it should be multiplying f num2 by 4, the 3.7 times 4, and then taking that and adding it to the 12 something. So that's what we should get this time. Let's run it. And we've got an answer of 27. And 27, well, let's see. 12.2, or actually num2, 3.7 times 4, well, it would be 16 if it was 4, so it's somewhere between 12 and 16. We add that to our to the 12.2, and so 27 looks like it may be a reasonable number. And so you can see here how I hope, how floating point math goes. Oh, I was going to show you with the parentheses. So let's go ahead and add parentheses around the f num1 and 2 so that we're forcing that math to be executed first. In this case, it should add the 12.2 and the 3.7 together before it multiplies. And this time we get a result of 63.6, and, well, let's see, 12 and 3, 15.9 times 4, that sounds about right. So I hope in this video you see how we can do floating point multiplication, or floating point math in general. Thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss any future episodes. Please check out and subscribe to our other Dan on Tech channel playlists as well. Thank you.